Listen, it's midsummer. It is so hot outside that your asphalt is practically melting. Your sweat glands are working overtime, and you are desperately looking for a way to cool your home without having to sell a kidney to pay your next electricity bill. So, what do? You walk into a massive, shiny electronics showroom. The sliding glass doors open, and bam! Right there at the entrance steps, you are hit by a magnificent, icy cold blast of wind. It feels like a literal glacier just pulled up to greet you. You look down, and there it is, a sleek, portable air cooler. Attached to the top is a massive, bright neon price tag that screams a fraction of the cost of a standard air conditioner. Your brain instantly starts doing some highly dangerous financial gymnastics. You think, wow, look at that cold air. It's right here, and it's so incredibly cheap. Why on earth would anyone waste money on a multi-ton air conditioner when this magnificent plastic box can give me the exact same Arctic feeling for the price of a few fancy dinners? Well, my friends, I'm here to tell you that you have just walked face first into one of the most brilliant, thermodynamically engineered traps in modern retail marketing. You are experiencing what I like to call the Great Showroom Mirage. And if you buy that unit based on that entrance blast alone, you are highly likely to end up sitting in your living room a week from now, covered in sticky sweat, staring at a noisy, humid box, wondering where it all went wrong. Today, we are stripping away the slick salesperson jargon. We are ignoring the neon price tags, and we are going to look at the cold, hard, unvarnished truth about air coolers. I'm going to reveal the dirty secrets, the showroom hidden parameters hide from you, the physiological quirks that will surprise you after you buy one, the genuine health risks of skipping your maintenance chore, and exactly how to decode the materials inside so you don't accidentally buy a giant, glorified paperweight. Let's unpack the physics of the showroom trap first, because this is where everyone gets fooled. Why does that air cooler feel like an absolute miracle machine at the steps of the electronics store? Is it because the manufacturer unlocked some secret, revolutionary cooling technology? Absolutely not. It's because that air cooler is essentially cheating by stealing the performance of the store's massive industrial-grade central air conditioning system. See, a showroom is constantly chilled by giant AC units hidden in the ceiling. Those ACs do two things perfectly. They drop the temperature down to a crisp 20 degrees Celsius, and more importantly, they strip almost all the moisture out of the air. They create a beautifully dry, crisp, climate-controlled sanctuary. When the store places a demo air cooler right in that environment, the ambient air is absolutely starving for moisture. The water on the cooler's pads evaporates at lightning speed. And because the cooler is pulling in air that has already been thoroughly chilled and dehumidified by a multi-thousand-dollar AC system, the air blowing out of its vents feels like a sub-zero blizzard. To make the trap completely foolproof, they place it right at the entrance steps where people frequent. When you walk off the burning hot street, your skin temperature is through the roof. Your body doesn't actually measure absolute temperature. It measures the sudden change in temperature. That contrast tricks your brain into thinking the cooler is an absolute powerhouse. Plus, by placing it near the swinging entrance doors, they ensure the machine gets a constant supply of fresh air movement, which keeps the humidity from pooling around it. It is a flawless, context-dependent illusion. But unless you plan to install a massive commercial air conditioner in your house just to keep your air cooler company, you will never, ever replicate that showroom breeze at home. The moment you bring that box into a real-world home, especially if you live in a coastal area or an area with high summer humidity, reality hits you like a wet blanket. Literally. Let's talk about the absolute elephant in the room, humidity. Air coolers are evaporative coolers. They work by pulling hot, dry air through water-soaked pads. As the water evaporates, it absorbs the sensible heat from the air, drops the temperature, and pushes out a humid breeze. The key word there is evaporation. If you live in a coastal city or any region where the summer humidity routinely climbs above 60 or 70%, the ambient air is already completely stuffed with water molecules. It's full. It has no more room to hold any extra moisture. So, what happens when you turn on your brand new air cooler in a muggy room? The water on the pad simply refuses to evaporate. The physics process completely stalls. Because there is no evaporation, there is absolutely zero cooling effect. But the little water pump inside the machine doesn't care about physics. It just keeps pumping away, forcing more and more unevaporated moisture into the room. Within an hour, your living room transforms into a tropical greenhouse. The air becomes heavy, sticky, and suffocating. Your skin feels perpetually damp because your own sweat can no longer evaporate to cool you down. You are trapped in a motorized sauna. And don't listen to the classic salesperson trick of just dump a bunch of ice cubes into the water tank to fix the humidity. That is a complete myth. Yes, adding ice will give you a tiny blast of cool air for about 10 minutes while the ice melts. But the second that water reaches room temperature, the evaporation stops again, and you are right back to square one. Except now, you've wasted your freezer's entire ice supply just to create a slightly colder swamp in your bedroom. But let's say you live in a dry area, so the cooling actually works. Are you completely out of the woods? Not even close. Now you have to deal with the operational surprises that no salesperson ever mentions while tapping on the glass counter. First up is the manual labor routine. An air conditioner is a set-it-and-forget-it appliance. You push a button on a remote, a little flap opens, and you enjoy your life. An air cooler, however, turns you into its personal butler. Depending on how hot and dry your area is, a standard 50-liter tank can empty itself incredibly fast. You will find yourself playing the bucket brigade game, hauling heavy gallons of water across your clean floors once or twice a day just to keep the machine running. If you forget, or if you get lazy, the pump runs dry, the pads dry out, and your cooler instantly reverts into nothing more than a giant, incredibly loud, oversized table fan. Speaking of loud, let's address the noise levels. Showrooms are vast, bustling spaces with background music and ambient chatter that easily masks equipment noise. Your bedroom at 2 o'clock in the morning, however, is dead silent. Air coolers rely on heavy-duty axial fans or high-velocity centrifugal blowers to push air across a room. Because these fans are completely exposed inside a basic plastic housing, they don't hum quietly, they roar. Sleeping directly in front of one can feel like laying your head down next to a regional jet idling on the tarmac. And what about your household assets? Since an air cooler continuously pumps moisture into your indoor environment, that clean moisture has to land somewhere. Over a few weeks of continuous use, the relative humidity inside your house stays permanently spiked. Expensive solid wood furniture begins to absorb that airborne moisture, causing the wood to expand, warp, and make your cabinet doors jam. The laminate sheets on your plywood wardrobe start peeling at the edges. Even worse, that airborne moisture settles on the sensitive internal circuit boards of your expensive electronics, your televisions, laptops, and gaming consoles. Over time, it creates microscopic layers of rust and corrosion on the components, leading to sudden, unexplained electronic failures. You think you're saving money on your electricity bill, but you might accidentally be shortening the lifespan of your $2,000 home theater system. Now, let's look behind the back panel of the machine, because what the cooling pads are made of dictates exactly how much pain you will experience down the line. When you are shopping for a cooler, you will generally run into 3 types of materials, and this is where you need to keep your eyes wide open. The first material is traditional Aspen wood wool. These pads look like a messy nest of shaved wooden wood chips held together by a thin plastic netting. They are incredibly cheap to manufacture, which is why budget coolers love using them. And to be fair, when they are brand new, they actually cool quite well because wood fibers hold water nicely. But here's the catch: wood is an organic material. When you repeatedly soak an organic material in water, expose it to hot summer air, and then turn off the machine, that wood inevitably begins to decompose and rot. Within a few weeks of use, an Aspen pad will begin to emit a highly distinct, sour, pungent, wet dog, or decomposing forest smell. Furthermore, the rough, irregular shape of wood shavings creates thousands of microscopic hidden pockets where dust and mineral scales can lodge themselves. Once a bacterial colony sets up shop inside those wood fibers, no amount of rinsing will ever get it out. You are stuck buying replacement pads every single season just to keep from gagging when you turn the machine on. The second, much better material is cellulose honeycomb. These look like a highly structured, engineered block of paper corrugated into a beehive pattern. They are significantly more expensive, but they are built to last. Even though they are technically made of a paper base, they are heavily treated with specialized protective resins and anti-rot chemicals during manufacturing. This prevents the material itself from absorbing water and degrading. They don't rot, and they don't create a sour smell on their own. The only trick with honeycomb pads is that their dense, matrix-like structure acts like a highly efficient air filter. They catch a massive amount of ambient dust and pollen. If you don't take a garden hose and rinse them down every couple of weeks, that trapped dust combines with the water to form a layer of muddy sludge inside the pores, which will eventually turn foul. But if you take care of them, a good set of honeycomb pads will easily give you 2 to 3 years of clean, odor-free service. The third material you might find, usually in ultra-cheap desktop or personal mini coolers, is a basic plastic or synthetic nylon mesh. Salespeople love to pitch this as the ultimate innovation because plastic can't rot and it never smells bad. And technically, they are right. Plastic will never develop a musty rot odor. But here is the thermodynamic catch that they conveniently leave out. Plastic is hydrophobic. It naturally repels water. When the pump drops water onto a plastic mesh, the water cannot soak into the material to create a uniform, thin sheet for evaporation. Instead, due to high surface tension, the water beads up into tight little droplets and instantly slides straight down the smooth plastic surface back into the bottom tank. Large sections of the mesh remain completely dry. When the fan blows air through those dry gaps, no evaporation takes place, meaning no heat is absorbed. A plastic mesh cooler is essentially a complete scam when it comes to actual cooling efficiency. It has a performance rating of less than 20%. It won't smell, sure, but it also won't cool you down even a single degree. It's just a fan with a water tank attached. But hold on, speaking of keeping those pads clean, we need to have a serious chat about the actual liquid you are dumping into this machine every day. The type of water you use directly dictates how long your cooler survives and how cold it actually gets. We need to talk about the silent killer of air coolers, hard water. If your tap dispenses hard water, meaning it is packed with dissolved minerals like calcium and magnesium, you are essentially pouring liquid concrete into your machine. Here is the science of why this is a disaster for your cooling effect. When hard water hits the cooling pads, the water evaporates, but the heavy minerals do not. They are left behind. Day after day, these minerals bake onto the pads, creating a thick, white, chalky crust known as scaling. Within just a few weeks, this chalky armor completely clogs the tiny pores of your expensive honeycomb pads. Remember what we said about evaporation needing surface area? Well, hard water scale destroys that surface area. The water can no longer spread out. It just cascades over the crusty scale and falls back into the tank. The air passing through the blocked pads doesn't pick up any moisture, and your cooling efficiency plummets from a crisp chill to absolutely zero. Plus, that scale eventually gets sucked into the water pump, grinding the internal impeller to a halt and burning out the motor. So, what is the fix? RO water. Reverse osmosis water, or any filtered, demineralized drinking water, is the absolute holy grail for an air cooler. Because RO water has had all the heavy minerals stripped out of it, it evaporates perfectly clean. It leaves zero residue behind. Your cooling pads stay soft, porous, and highly efficient all summer long, and your water pump doesn't have to chew through calcium rocks. And hey, remember earlier when I busted the myth about dumping ice into the tank? I know some of you are still going to do it anyway, just to get that temporary 10-minute blast of placebo winter. If you absolutely insist on throwing ice in there, you must use ice made from RO water. If you freeze hard tap water into ice blocks and throw them into the sump tank, you are just delaying the inevitable. As that ice melts, it releases all those concentrated minerals straight into the water supply, sending a superdose of calcium directly to your cooling pads. You might feel a temporary drop in temperature for a few minutes, but you are actively choking the lifespan of your machine. If you want the machine to actually cool your room efficiently for the whole season, treat it right, give it clean, filtered RO water. At the end of the day, an air cooler is an appliance built entirely on compromise. It is a highly specialized, niche product that has unfortunately been aggressively mismarketed as a universal, cheap alternative to the air conditioner. If you live in a landlocked, interior region with desert-like summer heat where the temperature hit 45 degrees, but the humidity drops to 15%, and you are operating on a strict monthly budget where a massive AC power bill would break you financially, an air cooler is an absolute populist savior. It runs beautifully on a basic home inverter during summer power cuts. It keeps fresh air moving through open windows, and it provides a massive amount of physical relief for pennies on the dollar. But if you live in a coastal area, if you hate high-maintenance schedules, if you are highly sensitive to equipment noise while sleeping, or if you simply don't want to spend your summer evening scrubbing mold off a honeycomb pad, that cheap showroom price tag is a complete trap. Save your money, bypass the entrance display, and invest in a proper air conditioner that can actually handle the humidity. Look past the marketing illusion, understand the physics of your local climate, and make a choice that keeps both your wallet and your lungs perfectly healthy. That is the absolute reality behind the plastic box. Thanks for hanging out with me today. If you found this breakdown helpful, do not forget to smash that like button, subscribe to the channel, and let me know down in the comments if you've ever fallen for the great showroom trap yourself. This is Sal, signing off. Stay cool, stay smart, and I'll see you in the next one.